Good morning, folks. I'm Lane Traxler, and welcome back to Weather Wonders, where we break down the science behind the skies. Today, we're chasing one of nature's most magical sights, rainbows. But what really creates these colorful arcs that make us stop, stare, and maybe even look for a pot of gold? So what are the steps? Good question. What are the steps that cause rainbows to form? Rainbows are formed through a beautiful dance of refraction, reflection, and dispersion, all happening inside tiny drops of water suspended in the air after a rainstorm. So that's why rainbows typically happen after rain, because you need tiny droplets of water in the air to form rainbows in the first place. The first major step in creating a rainbow is refraction. When sunlight enters a raindrop, it bends, aka it refracts, because it's moving from air into water, and air is less dense than water. This change in the medium causes the light to slow down and change direction slightly. So think of it like how your legs look bent when you stand in a swimming pool. That's refraction in action. Another fun fact about refraction is that it happens twice during the rainbow forming process. The first time refraction is used in action is whenever light reflects off the inside surface of the raindrop. The second time is when light exits the water droplet and bends again. That's called the second refraction. So what happens after all that refraction? The next step in our rainbow forming equation is dispersion. What is dispersion? So basically, dispersion is when light continues into the raindrop and spreads out into its individual colors. This is dispersion. Not all colors of light bend the same amount, so think about it like a prism. Whenever white light goes into a prism, multiple different colors come out. Why is that? Well, this depends on the light's wavelengths. So red light bends the least and violet bends the most. And sunlight separates in the full spectrum. That's how we form rainbows. Dispersion is one of the most key parts in the formation of rainbows, because without dispersion, a rainbow would just look like a big white light. Dispersion causes the red, orange, yellow, green, blue, and purple part of the rainbow, which is obviously the most noticeable part of the rainbow. Dispersion causes the bending from the white sunlight to split apart into separate color components, which is why we see the red, orange, yellow, green, purple, blue, and violet. The last and final step in our rainbow forming equation is reflection. So once the light has split into all of its different colors due to dispersion, it travels to the back of the raindrop, where it hits the inner surface and reflects. Basically, think of it like the light bouncing off a bunch of tiny mirrors. Without reflection, we wouldn't be able to see rainbows, and this is because the internal reflection sends the light, which is now a fan of separated colors, back towards the front of the drop. And as the light exits, it refracts again, which is the second refraction, if you remember, and it bends one last time as it leaves the water and re-enters the air. Since each color exists at a slightly different angle, that's why, when the conditions are just right, you see the colors appear in a beautiful arc across the sky. So, next time you see a rainbow after a big storm, remember that you're witnessing a dazzling display of refraction, dispersion, and reflection, all happening across millions of tiny water droplets in the air, with each water droplet acting like a miniature prism.